Hey guys, and welcome. I am a little under the weather right now. I've had a sinus infection for the past few days. Thankfully, it's not contagious, but we're going to go through a video here together. Bear with my voice as I'm going through this. I'm going to try to cover for you guys really what I see as being the essential equations on your AP Stats reference sheet that you need to be familiar with going into this test. And also, it'll give you a good sense of where on the reference sheet these equations are that you'll need. So I'm going to be referring to, from time to time, this Word document reference sheet that I've got here. I will, along with, let's see, a link to the video. What I'll post, I may remember to post a link to the video, but at the bare minimum, what I'll do is I'll post this Word file AP Stats reference sheet, which, again, you will have on the AP exam. I'll post this to the calendar for the most recent day that I would have seen you, even if I wasn't out for sickness on Friday. Okay, so it'll be in a different day depending upon the class that you have, either Thursday or Friday. All right, first thing we're actually going to look at is the y hat equals b naught plus b1x. Hopefully we can remember that. This comes from a scatter plot, or is used for a scatter plot, where you have met the conditions of linearity by looking at the r squared value in your residuals plot. So if my linear regression model looks something like this, the regression line, so first important equation is your y hat equals b naught plus b1x. Note there, again, that is on your reference sheet, left column in the descriptive statistics section, okay? And then closely related to that, you've got the second equation I want to look at with you guys is this b naught, your y-intercept, equals y bar minus b1 times x bar, okay? Now where does that come from? Well, every regression line, remember, goes through the center of your x data and the center of your y data. Okay, so I kind of missed it. I'll draw that dot really big. More or less, I've drawn this regression line to go through the center of the data. So if you want to find the b naught, the y-intercept, you just have to know the mean of y, the mean of x, and you've got it. So to get this guy, it's derived from the above equation. All right. Third thing, we're going to look at two things together here that are similar. You've got, well, kind of similar. Remember that when I talked about how to find the correlation coefficient, I keep telling you guys that it's the sum of the product of a z-score for x times a z-score for y all over n minus 1, okay? That would be how far this little point right here is from x bar, it's z-score for x, and how far it is from y bar, it's z-score for y, okay? All right, and you do that for every one of these points, and that's how you get the correlation coefficient. Well, on the AP Stats reference sheet, they don't give you quite that, but they do give you something right here that if you look at it carefully, you'll notice it's very close. Okay, so we've looked at the y hat equals b naught plus b1x first. We just looked at b naught equals y bar minus b1x bar. This guy is how to find a correlation coefficient, and x sub I minus x bar over s sub I, or excuse me, over s sub x, that is a data value minus a mean of x's over the standard deviation of x. So this is, in parentheses, a z-score for x. Similarly, to the right of that, you've got y sub I minus y bar over s sub y. A data value minus its mean over a standard deviation, that's a z-score for y. So this is a clunky way of them saying the correlation coefficient is the sum of the sigma there for every data value, the product of its z-score for x times its z-score for y, divided through by n minus 1. So it is the very same thing that I have taught you about in class, just represented in a clunkier way. Now you may ask, well, why would they represent it in such a clunky way on the AP exam? And that's again because on the AP exam, they're going to accommodate for people who don't have calculator access. You guys having calculators have a huge boon on some students. Now, like 99% of the students will have calculators, but a few are going to take this exam without graphing calculators, which is tough. But they're going to give people the equations to use to calculate these things manually if required. Okay, so that's your correlation coefficient equation. Last thing on this slide I really want to look at is the B1 equals R Sy over Sx. Okay, so fourth up here, B1 equals R Sy over Sx. So that's how to find the slope of your regression line. You just take the correlation coefficient times the standard deviation of y, divide through by the standard deviation of x, and there's your slope of the regression line. Notice R, Sy, and Sx winds up giving you a, well, let me think for a second. It winds up giving you a number such that, let's say your slope came out to be 5. Well, the standard deviation of y has units. Maybe, I don't know, maybe you're looking at how number of glasses of milk is x determines maybe height in feet for y. Okay, so maybe that's how we built the scatter plot. Okay, if we get a slope of 5, we're saying that our slope is really 5 over 1 for every, if y is the numerator, for every 5 feet, which seems outlandish, it's really big obviously, for every 5 feet, maybe that was a result of, or we could predict that from an extra 1 glass of milk drank weekly. 1 glass of milk. Okay, so they may ask you to interpret your slope. Just remember that that's y over x. Pay attention to your units of y and x when asked to interpret your slope. Okay, all right, so there are 4 important equations from your AP Stats reference sheet. Let's go on to, excuse me, slide 2. Let's talk about probability stuff. We're going to talk about, let me point to you where these are. On the reference sheet, we're going to look at first, second, third, and fourth, all under the probability column. These are important. Okay, so if I've got a probability sample space is 100% of all the outcomes for a random event. And over here, I've got event A. Over here, I've got event B. Okay? And if I ask you, what's the probability of A or B, A union B? Well, you can see clearly that that's going to be the probability of A, okay, plus the probability of B, plus the probability of B. But the problem is that now we've included the intersection 2 times, okay? We don't want to include that intersection 2 times. So we're going to subtract off the probability of the intersection of A and B, okay? And that's how I find the probability of either. Now, notice if these 2 events are mutually exclusive or disjoint, meaning that there is no intersection right here, the probability of A and B is equal to 0. You wouldn't really need this piece if A and B are disjoint. But this right here will allow you to find the probability of A or B given any 2 events, regardless of whether or not they're mutually exclusive or if they can both occur, meaning that the probability of A and B was greater than 0, or they could both occur, okay? Next up, let's take a look at the probability of A given B. That's given to you. Most of you guys know this by heart, but that's the second equation given to you under the probability section. Probability of A and B is your numerator. Okay, well that's everything right in here. Divide through by the probability of B. That's that B could occur at all, that whole circle, okay? So and that should make some intuitive sense. If you're looking to find what's the likelihood that A occurs given that B occurs, I'm not going to divide through by 100% of all the sample space, because I already know that event B has happened, and I want to see if A can also occur, okay? Hence that red shaded sliver, divide through by the now blue circle representing event B. Okay, let's go on to something just a little bit different. Let me draw for you or define a variable first. Let's say the random variable x is the roll of a die. Roll of a die. Okay? And this die we can represent on a probability table with sides, let's go something crazy, 2, 5, and 7. It's only a 3-sided die, or maybe it's got 6 sides and it's got repeats of each of those sides. So here are, that's lowercase x, those are the individual values that the random variable x can take on. So this is what happens after the random event occurs. X being boxed represents the random event generally. Okay? So the probability that your random event generally takes on any of these specific values, capital X equals lowercase x, is, let's say we've got 0.5, 0.3, and 0.2, and the expected value of this is the third equation on your AP Stats reference sheet. The mean of this random event is represented on your reference sheet as the sum of x sub I, p sub I. Okay? What is that? That is the sum of each different outcome times its probability. 2 times 0.5 plus the sum of 5 times 0.3 plus the product 7 times 0.2. Okay, so you get, for a total expected value, you get 3.9. And then you go on to the variance. Variance of x is calculated as the sum of x sub I minus mu sub x squared times the probability sub I. Okay? So this is the sum of each individual value, so 2 minus the mean that you got from the expected value above, 2 minus 3.9 squared, times the probability that event occur, which is 0.5 from my probability table, plus, do the same thing again, 5 minus 3.9 squared times its probability of 0.3, plus, finally, 7 minus 3.9, minus 3.9 squared times 0.2. Okay, it gives you a total variance of 4.09. So if I wanted the standard deviation, I'd say, well, the standard deviation of x is equal to the square root of that 4.09, which I'm not sure what that is exactly. I haven't calculated it, but it's approximately 2. Okay, approximately 2. All right, so there's sort of the meaning and the placement of 4 important probability equations that you'll want to know where they're at on your reference sheet. Again, if for some reason I have not given you a copy of the stats reference sheet, I think I have, and I think I've tried to do that multiple times this semester, but even if you've lost it, let me know. I can print that off for you very easily from the MathPod printer as need be during class, just like I would a bell ringer. No problem there, okay? All right, so slide 3, where are we looking now on the reference sheet? We're going to look at, directly below, at the 1, 2, 3 next equations. The probability of a binomial distribution, the mean, and the standard deviation of a binomial distribution. Okay, so let's say we got Mr. King, LeBron James, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different slots here representing hits or misses on free throws. Okay, so he's taking 10 free throws. Let's say we want the probability. What's the probability James hits, let's see, 7 of 10 if P, his probability of success, is equal to 0.6 or 0.60. Okay? All right, so next equation up, they give to you as the following. They say that it is the probability of x equals lowercase x, capital X equals lowercase x is equal to n choose k. Okay, n is the number of trials, which here you can see is 10. Okay, k is the number of successes, here you can see is 7, times p, your probability of success, to the kth power, times q to the n minus k. Okay, what's the meaning here? Well, this chunk should be relatively intuitive. If we want to know the probability that LeBron James hits 7 free throws out of 10, we should say, well, we know that we're going to have to take 0.60 to the 7th power, okay? So he's 60% free throw shooter. We're going to multiply that together 7 times. And then what's left, Q, that's 40%, his probability of missing, to the 10 minus 7, that gives you 3, okay? So this right here, the portion below the bracket that we have written, that gives you the probability of him making 7 of 10 a single particular way. Maybe that is a hit, 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 and then followed by 3 misses, okay? But that's not quite fair. You still have this chunk right here that deals with the fact that your hits can occur in multiple positions. You could have the hits arranged as the first 7, and then he misses the next 3, or you could see something, I'm not going to say more bizarre, but just different. Hit, miss, hit, hit, miss, hit, hit, miss, hit, hit. Okay, so there's his 7. So this n choose k, 10 choose 7, multiplies that individual probability right here that he hit 7 of 10, and then this guy accounts for all the different ways that can occur. That's your binomial distribution. Most of the time you guys have used binom PDF or binom CDF to just calculate this sort of probability, and that's fine. But as you've seen, the multiple choice questions sometimes will ask you about this meaning. Well, go back to your reference sheet when you see that. Don't just take a shot in the dark. Try to interpret the reference sheet and what it's got for you. All right. So the next 2 equations here real quick are mu sub x in p. Okay, mu sub x equals np. Well, this is just the mean. It's the same as the expected value of x equaling np. That's the mean of the number of shots he would make of 10. Well, he's got 10 trials, 60% probability of success, so you'd expect 6 shots to be made. Okay? And then directly below that, they give you another equation, which looks like sigma sub x, sigma we know is standard deviation, equals the square root of, they put np times 1 minus p. Well, remember, 1 minus p, that's just saying the complement of p. What's the complement of p? Well, q is the complement of p. So this is the same thing as the standard deviation of your binomial random variable equaling the square root of npq, which is, where's going to plug? Okay, square root of 10 times 60% times your 40%. So the standard deviation of the number of shots he would make would be, I believe, 1.55. Okay? And there you go. There's some of the binomial stuff. I know Blair and Morgan had in particular asked about some of this stuff. Blair's done an awesome job of vocalizing where she's confused, where she isn't. I appreciate it, Blair. Not trying to embarrass you. I honestly appreciate it. All right, so let's see. From there, let's go to some of the standard deviations on back. So there's the important stuff that I have seen from the front of the AP Stats reference sheet. Yeah, you could nitpick and say that there's some other stuff on there that maybe you would need. I think those are the biggies for sure. And then on the back, they give you your standard deviations of statistics. So right here, excuse me, they give you, if you're using a bell curve to talk about sample means, maybe think of that as a bell curve to represent how groups of 20 students at Yorktown would be in terms of average height. Okay? This sigma over the radical n, that's the standard deviation for that bell curve. Okay? And I'm not going to draw that. I will talk, part of the reason is because the standard deviation of the sample mean, standard deviation of the sample proportion, and the standard deviations of differences between means and proportions below. I'm going to talk about these further in an upcoming video because I think that sample stuff is still tricky for us and we need a recap on that. Okay, so here's your standard deviation for a bell curve representing sample means. Here's your standard deviation for a bell curve representing sample proportions. Notice again they're using 1 minus p as a substitute for q. Okay, so not a hard thing to make note of mentally. You've got your difference of sample means here. You've got your difference of sample proportions here. Well, there are two things that I would observe. When you don't have sigma, sigma is your population standard deviation. When you don't have sigma and you just have a sample standard deviation, that's when you're using a t distribution instead of a normal bell curve. And you need to pay attention to your degrees of freedom when you don't know that population standard deviation. Same is true for differences of sample means. If you don't know the population standard deviation, that's when you're using the t distribution. The only thing I want to add to the difference of sample proportions is remember that when you make a hypothesis test for a difference of sample proportions, in general, the null hypothesis is that there's no difference between your population proportions. So that would be like P1 minus P2 equals 0. Well, you need to pool right here. Wait, oh, it's not going to do it for me. Okay. Anytime you've got a hypothesis test focusing on the difference of sample proportions, pool your sample proportion before you calculate that standard deviation.